Malaria is a disease caused by Plasmodium parasites, transmitted through female mosquito bites. In serious cases, malaria can cause seizures, coma, and death. There are an estimated of 228 million cases and 405,000 deaths worldwide every year, with 93% of cases and 94% of deaths occurring on the African continent. In many of the heaviest hit countries in Africa, there is a lack of access to healthcare and screening for malaria. Cases are confirmed using basic light microscopy to examine thin blood smears. However, this method is tedious and heavily dependent on technician expertise. To address this severe malaria endemic in Africa, we proposed an automated screening method that is driven by a series of neural networks. First, we use an object detection model that detects the presence of red blood cells in thin blood smears. Then we have an image enhancement model that increases the image resolution should the original images be too blurry. Lastly, we have the classification model that processes the image of each red blood cell to see if it is infected or not. The object detection model has yet to be fully optimized, but the current prototype achieves an average precision of 90.4% and average recall of 63.9%. Here we show an example image of red blood cells detected in a thin blood smear on the left. In the middle, we have samples of infected red blood cells and see that our neural network model is scaling the low-resolution images into high-resolution images quite well. Meanwhile, the classification model achieves an accuracy of 96.5% as well as a sensitivity of 97.4% and a specificity of 95.6%. While the object detection model was trained on a dataset from the Broad Institute, the image enhancement and classification models were trained on a dataset from the NIH. Because the models were trained on separate datasets, we show the object detection and classification models separately. Here in the first series of videos, we see that the mobile phone can detect most of the red blood cells, although clearly a few are missed. In the next videos, we see the mobile phone is able to successfully detect the presence of parasites in red blood cells. Meanwhile, the model is also able to equally detect the absence of parasites in uninfected red blood cells, as shown in these videos.